Hello and welcome to this live COVID-19 talk organized by Internews. I'm Sunny Krishnan, the Regional Health Advisor for COVID-19 in Internews Rooted in Trust project. Now the big question is, can we get COVID-19 twice? So how should we receive the news on reinfection of recovered individuals? If there are looming fears of COVID-19 reinfection, there's naturally immediate doubts over how far a vaccine could work if a person's antibodies or immunity aren't strong enough to fight off future infections. Does it mean a COVID-19 vaccine won't really be that effective? With us today, to help answer these questions is Dr. Jaya Shreedhar. Dr. Jaya is a pandemic health journalism mentor with Internews. She's a trained medical doctor and a journalist and a writer. And now a couple of housekeeping instructions. This COVID-19 talk today is live on both Zoom and Facebook. If you have joined us on Zoom, you can post your questions in the chat function of your dashboard. If you've joined us on Facebook, you can post your questions in the comments section of the feed. So without much ado, let's go over to Dr. Jaya Shreedhar. Thank you, Dr. Jaya, for joining us today.
Pleasure, Sunny.
My first question to you, Dr. Jaya, is what scientific evidence is there that one could get COVID-19 twice? And also, can you give us a background on the recent cases of reinfection? Thank you.
I think it's the right question to start with. Let's look at whether these cases of so-called reinfection have been verified or not, whether they're actually true first. I think that's a good place to start. And there's been 2 confirmed cases so far. And when we say confirmed, they've offered the evidence in peer-reviewed scientific publications. And so we take them to be true. There's a third one from Belgium, but that case hasn't been reported in a peer-reviewed publication as yet. So if you look at the first case, it's a 33-year-old man from Hong Kong who got infected in March, and then he sort of became well, and then he went to Europe to travel, and on his way back to Hong Kong, he got screened at the airport and ended up testing positive again. So that was the first confirmed case. And now there's been a second one from Nevada in the United States, Reno, where you have a 25-year-old man and who tested positive on PCR sometime in April, and who sort of fully recovered by May, and he tested negative again on a polymerase chain reaction test twice, and then again in May he fell sick, and he was found in June to be positive, and so sick that he actually needed oxygen. So in both cases, the researchers analyzed the genome of the virus and found them to be from 2 distinct clades. So a clade is essentially a slightly different subspecies or a strain of the SARS-CoV-2, which has a very, very slight deviation, but enough to make it belong, enough to categorize it into something called a different clade. So it's established that these 2 belong, the 2 infections, 2 reinfections in both the cases, both in Hong Kong as well as the Nevada, belong to 2 different viral clades. So that's how it's been proven that these are reinfections. Of course, there's no data that's been offered by either researcher that there might have been contamination of the viral samples, because in busy clinics that are dealing with plenty of viral samples, we don't know if there's been any sort of possibility of contamination, but neither papers really mentioned that. So we'll take them at face value and consider them to be true infections.
So, Dr. Jaya, what are you saying? Are you saying that there are different clades of the virus circulating in different parts of the world? And also, can you explain in simple terms for us journalists what is a clade? Is it a mutation, or is it a different strain or that's circulating?
Right. So the SARS, the coronaviruses are the broad, larger classification under which you have viruses that cause SARS, the first SARS as well as now SARS-CoV-2 and so on. And the coronaviruses are called so because of their crown-like spikes on the surface. Now there are 5 or 6 clades in circulation all over the world right now, and this particular clade, which has been identified in Hong Kong and the one that's been identified in Nevada, they are distinct and different from the strains that infected the same people a few months earlier. So it is just a very, very small genetic mutation in the virus, which is sufficient to set it apart from its parent, but not enough to really have a consequence on the course of illness in the person or to alter their hospitalization outcomes. In other words, it's not a serious mutation, but it is a mutation. Somebody called it to, someone wearing a green t-shirt one day and a blue t-shirt the other day. So it's not a consequential mutation, either of these mutations. But we'll have to wait and see if there are additional new mutations that are going to come, which might have adverse or serious consequences, for instance, on vaccine development. But that awaits to be seen.
Yeah. My next question, Dr. Jaya. What happens in our body when our immune system is faced with a foreign virus, a virus that is alien to the body? And can you explain how the immune system works? What happens? How does the body try to fight this virus? And what does it mean for COVID-19? We hear terms so much, so many terms like, T cells, memory B cells, white blood cells, etc. So can you explain to us the whole immunology behind, in simple terms, behind this, how our body tries to fight off the COVID-19 virus?
Generally, Sunny, we're blessed with very good immunity. Otherwise, we wouldn't survive as a species. So there's essentially 2 kinds of immunity that we have. One we're born with and the other we develop. So the one that we're born with is called the natural or the innate immunity that all of us are born with. And it starts with something as simple as your skin, which helps to keep out, fungi or worms or parasites and so on, doesn't allow it from getting into your body. And it also has a number of things inside your body, like the white blood cells, that know to recognize any fungi or bacteria or virus and sort of attack it and gobble it up. And there's also chemicals inside the body, antiviral substances called interferons, for instance, that attack viruses. And all these kinds of immunological defenses that are mounted by the body are non-specific. It doesn't have to be a SARS-CoV-2 infection for you to start fighting it. It could be any kind of bacterial infection or a viral infection. And for this reason, the immunity that is inborn with you, the natural immunity, is called a non-specific immunity. So that's one huge kind of immunity that we already have, which is making us quite capable of fighting off a series of infections from invaders, including from viruses like SARS-CoV-2. So when a baby is born, what kind of immune system does the baby have? It's not mature and so on. So it gets a lot of the immunity from the mother's, blood through the transplacental transfer. And that kind of immunity where the baby hasn't made any special chemicals to fight infections, which are called antibodies, I'm coming to that in a minute, it gets from the mother. And it also gets these antibodies from the breast milk. The antibodies are something called a specific immunity, and that is something which we are not born with. We acquire it over the course of our lives as we get exposed to a number of bacteria or viruses or other kinds of infectious organisms. So when a new virus or a bacteria invades us, our immune system has special cells called B cells, and they recognize this as an antigen. An antigen is nothing but an organism which generates antibodies. That's an antigen. So recognizes it as an alien invader and creates tiny protein missiles, molecules called antibodies, which go and sort of bind to it like a lock and a key, like locks going and binding to these keys and preventing them from entering cells and establishing infection. So this is something called acquired immunity. It's something that you acquire over the course of your exposure to various antigens or pathogens that enter your body. And unlike innate immunity, it is specific. So each antibody is very specific to a particular virus or a particular bacteria that enters your body. And these antibodies that are able to sort of engulf these, specific parts of the virus and prevent it from entering your cell and neutralizing it in effect, neutralizing it from being able to establish an infection, they are called neutralizing antibodies. And journalists will see a lot of that term when we talk about vaccines. They're very, very important. So broadly speaking, these are the two major kinds of immunity that we have. One is innate, which is non-specific, and the other one is acquired, which is specific. When it comes to SARS-CoV-2, it is the specific immunity that we really need to think about and discuss and learn about.
Yeah. My question, Dr. Jaya, now coming back to our main topic on COVID reinfections. What actually went wrong with the 33-year-old man from Hong Kong? What happened to his immunity system? And, and how did he get reinfected with COVID-19? Is it something common, or is it an anomaly, or is it an outlier?
It seems like these early couple of cases of SARS-CoV-2 infection are, as you said, outliers. I mean, consider the numbers to start with. If you're looking at over 27 million infections all over the world, and there are only a few reported confirmed cases of reinfection, it tells us that reinfections may not be common at all, and these may just be outliers. There's a good chance that we're going to find out how much more common reinfections could be, because infections are dipping in many of the European countries, through July and so on. And as the lockdowns are being lifted, infections are beginning to spike again. And as the infections sort of spike again, many of the people that were infected earlier are going to be re-exposed to the new lot of infections. And that's when we have to watch out to see if more reports of reinfection happen. So what went wrong with the man from Hong Kong? We don't know. Many unanswered questions. But the first time that he sort of got the virus, he produced quite a robust immune response. He produced neutralizing antibodies, and his C-reactive proteins were also good. C-reactive proteins are nothing but a small marker to tell you that there's inflammation in the body. So, it's very commonly used for heart disease and for cancer and so on and so forth. And a C-reactive protein becomes valuable when someone has symptoms of COVID-19, because there's a lot of inflammation going on within the body, and the C-reactive protein sort of indicates that. So he did have a fairly good immune response. And then what happened after a period of time in the intervening months, we don't know. So it could be that his immunity waned over a period of time, and that's a real concern also for vaccine development. So how long can we sustain the levels of antibodies once we get sick with SARS-CoV-2, once we get infected? How long can we sustain those levels of neutralizing antibodies is something that's still being looked at. But early reports seem to hint that immunity could wane.
Okay, coming back to waning immunity then, what does the medical and scientific evidence say? How long do the neutralizing antibodies last? Been reading a couple of journal articles saying that it can be between 4 months, it can be, for some it's 3 months. So what does it mean in the search for a vaccine for COVID-19 if the neutralizing or antibodies last for only such a short period of time?
This is a really important question and something that's being researched a lot. So we still don't know the answers. But let's look at a country like Iceland, which has not had a lockdown, which where people have been sort of the levels of exposure have been high, and there was a study recently that sort of measured the levels of antibodies over a period of months, and they say that at about 4 months and onwards, the up to about 4 months or so, the antibody levels, the titer, as they say, remains quite good. And then after that, then you begin to sort of see it wane. So waning immunity is something that is indicated, post a SARS-CoV-2 infection. And the implications for a vaccine are that you might need to give booster doses in case this waning immunity is widely established. And we have enough data from several countries to show that waning immunity is indeed a genuine problem with COVID-19. Otherwise, generally with coronavirus infections, once you get infected with the coronavirus, the immunity lasts from 1 to 3 years generally. And SARS-CoV-2 being a coronavirus, we would imagine that the immunity should last longer, but we will soon find out.
So there is a slim possibility or a slim chance that we could be seeing sterilizing immunity, for a long period of time. And what you're saying is we should be prepared for waning immunity with the neutralizing antibodies lasting for a short period of time. And it is a given fact that the vaccine, we need to get booster shots for the vaccine. Yeah?
That's what it looks like right now. But on the point about sterilizing immunity, well, what is sterilizing immunity? It is once you get exposed to an infection, you fall sick with it, like for instance, measles, you don't get it a second time in most cases. Of course, there's always exceptions, but this is the principle on which the most successful vaccines seem to work. That you give, the smallpox vaccine or the polio vaccine, you give it once and then it produces an immune response in the body which sterilizes, which does not allow that infection to re-enter and establish infection and disease in you again. So that's sterilizing immunity. And that's sort of the ideal that every vaccine candidate is sort of, aspiring for, to be able to produce sterilizing immunity, which affords you protection from SARS-CoV-2 for the duration of your lifetime. I mean, many of the vaccines that we have today have saved millions and millions of lives of children under 5 because they've offered sterilizing immunity to the children who got it. So that's a very strong thing that particularly the people who have doubts about vaccines and vaccine science, it would do well to remember that vaccines have been the single most cost-effective, life-saving medical technology that science has ever offered to the human race. So that's really, really important to understand.
Right. Thank you, Dr. Jaya. Just a housekeeping note here. If you have any questions, and if you're already registered on Zoom, you can use the chat function on your dashboard. If you're following us on Facebook, you can send in your questions to Dr. Jaya in the comments section. We are monitoring. We are monitoring also Facebook, so don't worry, your questions will be answered. Dr. Jaya, now we come back to something very practical. How can we journalists report accurately on reinfections? This is, we don't want to scare anyone. We don't want to misinform anyone, and we don't want to sound sensationalist. So how can we go about reporting reinfections accurately?
Yeah. Sunny, you will agree with me that there's been a sort of an over-reporting or an over-stressing about the reinfection story, and there's been a bit of unnecessary panic created, which is why I think the first thing journalists should think about is, as I said, as we opened the talk, are these really true reinfections? That's the first thing to establish, and one would do that by checking on the source of that data. So, does it come, from well-established scientific institute, and has the, sort of finding been peer-reviewed, and has it appeared in a scientific publication of repute? That's one of the things to look at, and is the government endorsing that? That would be, the second thing. So, if it has a high degree of scientific credibility and an official endorsement accompanying it, I think we can take it as true. This is a true, a verifiable source, and you could report on it. And the second most important thing, I think, is also to put the numbers in context. We're still talking of over 27 million infections and only about a handful of anecdotal and confirmed cases. So the
It's
should we
2:30.
start creating panic in the minds of our readers? Not yet, unless there are large population-based studies which prove that reinfection is a very, very large problem. So unless there are large population-based studies that show a high degree of reinfections happening over a period of the next few months, I don't think journalists should create panic in the minds of the public that, I don't have to wear a mask because I'm going to get reinfected all over again. So it might have a very, very adverse effect on preventing transmission if you create despondency in the minds of the public about widespread and fuel fears of reinfection. That's the second thing. I think the third thing is also to ask the right questions to see if it's truly a case of reinfection. There might be many doctors who approach journalists saying that, I have 5 cases of reinfection. You're seeing only 2 cases, you're saying are confirmed, but I've been seeing this since, April or May. So how do you make out? You can ask a few commonsensical questions. The first one being, what was the period of time that elapsed between the first infection and the second one? And if it happened within a period of 7 days or 14 days, it could just be what they call repositives. Maybe the person never turned negative in the first place. So what could have gone wrong? If after a period of admission in the hospital with symptoms of COVID-19, you get discharged, they do a nasopharyngeal swab where they insert sort of a swab deep into your nasopharynx above the roof of your mouth to get at the back of your nose, nasal cavity just above your throat passage, and take a little sample and test it to see if you've turned negative. Now, if the swab doesn't reach deep enough to pick up deeper virus, which means you're still positive, it could give a negative result, which is a false negative result, which is why the WHO recommends you do 2 tests to make sure that you are negative before you get discharged from hospital. But then if you don't do the test properly both times, it's quite possible that it could be a negative false positive. So such a person who after a period of about a week or so, just goes and has another test could well think that, oh my God, the hospital told me I'm negative, but here I am testing positive again. So check whether the tests have been done, 2 tests were done, and whether any other kind of test has been done. You can pick up SARS-CoV-2 infection results. You can test the stool, you can test your cerebrospinal fluid, you can do other tests. So it doesn't just have to be the nasopharyngeal swab. You can verify if it's a true reinfection by looking at what other tests have been done. So these are, some of the ways in which you can make out whether it's really a reinfection or not. And we also have to remember that sometimes people who have had a false negative with a nasopharyngeal swab just walk into a clinic because they're sort of, worried about this, and they take a blood test and they find out that they're positive. But they may not necessarily have live viral particles in them capable of transmitting infection to others. It could just be a false positive on a PCR, which is such a sensitive test that it can pick up fragments of dead virus. So that doesn't mean that you're infectious, that doesn't mean that you have an active infection, but you have to be careful about, panicking over a second positive test. So these are some of the things to watch out for. And there's no getting away from it, Sunny, unless we do the homework and learn the science, unless journalists learn the basics of immunology, some basic things about immunity, basic things about the test. There's no way that we're going to be able to improve the quality of our commentary when we're reporting about these very, very things important things that can cause a lot of stigma and unnecessary panic and worry in the minds of the readers.
Yes. There have been a lot of, coming back to immunity again, there has been a certain amount of debate and also a certain amount of journal articles published on herd immunity. Can you tell us what is herd immunity? Are we seeing the emergence of herd immunity? Before you answer the question on herd immunity for COVID-19, maybe you can explain to us what herd immunity means in diseases like measles and chicken pox and all that.
Let me just show you a sort of a graphic which will explain it quite nicely. So if you look at the screen, can you see the screen?
Yes, I can.
Yeah. So if you look at the screen, you'll find in the group on the far left, to my left, you'll see that the green figures, the bluish green figures are the ones who are vaccinated. The gray figures are those who have not been vaccinated and are therefore vulnerable. And there's one orange figure there who is infected with an infection. Let's just say measles, okay? Now, if nobody is vaccinated, I mean, like a good number of them aren't vaccinated, as you can see so many gray figures, this infected person is able to transmit the infection to all of them quite easily, except for those who have been vaccinated, and you can see that they remain protected. Those are the bluish green figures. Now, if you switch your attention to the figure on the right, let's say there are lots of people who are vaccinated, right? There's one orange figure who is infected, and there are fewer people who are uninfected. And the chances of the fewer uninfected people coming into contact with the infected person are therefore less. And so you have a fewer number of infections. So what large-scale mass vaccination does, even if you don't vaccinate every person who is vulnerable to an infection, if you vaccinate a good number of them, the chances of an infection spreading widely in a community are reduced to a very, very minimal level. So herd immunity is what is achieved because of large-scale vaccination. So if there is, for instance, a virus which can sort of produce, sterilizing immunity, which means once you get it and you don't get it again, like in the case of measles, then very many people in the community who have sterilizing immunity, the level of infections are going to be very, very little. Or you could have contracted it once, you don't get it again, and then you sort of, if that is transmitted to many people in the community, there's enough people who've had the infection and recovered from it with sterilizing immunity that it protects a huge portion of the population all over again. Works just like a vaccine, a natural infection working just like a vaccine. So the question for SARS-CoV-2 is, as was said in the early stages, so if this virus doesn't really we don't have a vaccine as yet, and many people transmit the infection to others, then will we achieve herd immunity naturally? Like a huge proportion of the population will become infected, become immune to it, and then the rate of transmissions will be slowed down to practically a very, very small number. Well, now the single most important question here is how long our immunity is going to last, isn't it? If we're going to see waning immunity to SARS-CoV-2, which doesn't protect you for more than about 5, 6, 7, 8 months, it still remains to be seen, then herd immunity is not going to protect us. So herd immunity works best when it's sterilizing immunity. Otherwise, it's still going to expose people to a lot of risk.
Okay. This is a question that had been submitted earlier by Eileen McCormick, and this is a question from a friend. Her friend has had COVID-19, was infected, and she is suffering from a chronic disease. She fears that she could get reinfected by COVID-19 again because of her comorbidity with this chronic disease. What's your advice, Dr. Jaya?
Wear a mask, maintain physical distancing, disinfect your surfaces, stay home as much as possible, and wash your hands frequently. I think these are golden principles that we have to follow, whether we're not infected, whether we're infected, asymptomatic, don't know it, whether we're infected and pre-symptomatic and about to, develop symptoms, or whether we've already had a mild illness or a moderate illness or are severely sick. The entire spectrum of all of these kinds of manifestations of SARS-CoV-2, or whether you're not infected, you just have to maintain these prevention precautions diligently, and that's ultimately what's going to prevent reinfections if they're going to happen on a large scale. They're also going to protect people who've already had a bad episode, who've been severely sick, from getting reinfected a second time. So that's a good question, because if your immunity has been compromised because of another illness, if you're already immunocompromised and you've had a serious bout of sickness with COVID-19, it really emphasizes the importance of these precautions. Along with it, you need to take great care to sort of take very good care of your health and get your vitamin D and your C, the other vitamins that your doctors prescribe, and make sure that you follow all the treatment recommendations, and your sugar control, or if it's heart disease, make sure that those comorbidities are taken care of, and keep your spirits up. That has a huge effect on immunity. It's very, very important to maintain a very healthy mental outlook, develop a lot of enthusiasm and grit. It's important. Some people may get it from prayer, others get it from family support, from good counseling. So take help from wherever you can, but you don't have to panic and worry about it. The more one panics and the more one worries, the more disempowering and the more your immunity drops. So it's important to also maintain a very, very healthy, positive outlook.
Yes. One thing you mentioned, Dr. Jaya, and which I've been reading a lot recently, is you mentioned vitamin D, and there are studies on the benefits of vitamin D. How do we journalists report on that?
Cautious. I would say cautious. I would say that, Sunny, my sort of take on this is, don't depend on vitamin D and vitamin C or any of the other friendly advice that you're getting. The proven ways of preventing reducing the risk of transmission is really your wearing well-fitted, triple-layered masks, washing your hands, and maintaining physical distancing and staying home, particularly maintaining your distance from people who are more vulnerable to infection. So I think vitamin D needs to be reported on with a bit of throw these things in as well. I think that's the single most important message. That while vitamin D can help to sustain your immunity, Sunny, boosting your immunity is not something that should be linked to a headline with SARS-CoV-2, because we know that the immune system and SARS-CoV-2 interacts in very many strange ways. So we don't want an overreaction of the immune system to this virus, which has ended up causing a lot of problems. We've already learnt about these cytokine storms, causing a lot of hyperinflammation, which is not warranted and which is killing healthy cells. So immune boosters or vitamins and other supplements that will boost your immunity, that's loose language. It's not really a science journalism. So I would say temper the reporting about anything that claims to boost your immunity, and instead focus on the science, the proven science, which shows that you can prevent the risk of transmission by these 4 standard measures.
Okay. There's another question that has come in, and it basically a person wants to know. I have had COVID-19 before. I just recovered. Why should I get? Why should I get a vaccine? Why should I be vaccinated? I've had it before.
We don't know yet whether people who have had one bout of COVID-19 will never get reinfected or fall ill with COVID-19 again. And that's a good enough reason why we need to follow vaccine development with a lot of interest. So generally SARS, coronavirus infections, usually from available evidence, don't afford immunity to the person for more than 1 to 3 years. So no one wants to fall sick with this infection or go to COVID-19 for a second time. So it's very important in the absence of evidence to show that one infection gives you sterilizing immunity for life. It's very, very important that you continue to follow the development of the vaccines, and it's a good idea to get vaccinated once we get a good vaccine.
Yeah. I think we have time for one more question. So if you have any questions, just put them in on Facebook comments, or if any one of you is watching it on Zoom, you can use the chat function in your dashboard.
I'd like to, while you wait.
Yes.
Yeah, I'm just want to say one more important story around the science of reinfection that needs to be followed is whether those who are reinfected are capable of transmitting the infection again to others. And that's another story that needs to be followed. So are they more infectious the second time around, or what happens? That's something that needs to be tracked closely. And I think with larger studies, we can track the reinfection story better.
There's one question that has come in. What are the resources you recommend for journalists to use when they're reporting on immunity issues and reporting on vaccines, and also trying to report on reinfections? What are the resources? Where can we go for deeper information?
I don't know how familiar people are with Google Scholar. This is something that I always ask the journalists to do, to get familiar with reviewing the abstracts on Google Scholar as much as possible so that they get familiar with what's happening. But an easy first place to start would be to go to the WHO as the first stop to check up on what's happening in relation to vaccines. They have very, very good resources which give both general explanatory stuff about the basics of vaccines and about the basics of immunity, how vaccines work, how immunity works. And also, if you want to check up on the latest developments, go to Google Scholar, look for peer-reviewed publications on SARS-CoV-2 vaccine development and on things like reinfection and immunity. Look at the abstract and then see whether that's giving you ideas for stories, and talk to experts, talk to people who know about reputed people who are there in reputed government approved institutions in your country, who can explain these things to you, to break down claims or to break down the scientific information. So these are a couple of good places to go to. I would also recommend the CDC. CDC also has excellent glossaries and primers on vaccines and immunity. So that's another good place to go to. So
this is the US CDC, yeah?
US CDC. So these are the two places that I would recommend to sort of, start with stuff.
You're from India, and this is my last question. Can you tell us, there's some vaccine development in India too, and I think India is also the pharmaceutical companies over there are also in partnership with the pharma companies that are also in trying to come up with a vaccine. Can you tell us a bit about COVID-19 vaccine development in India?
Yeah. I think more than the native vaccine development, I think the story really to follow is our capacity to manufacture many, many millions of doses at a lower cost and help satisfy the demand for the vaccine uh, if and when we get a vaccine in hand. So, the Serum Institute in Pune, in India, is capable of producing billions of doses of vaccine, and they've already entered into, sort of contractual agreements to, start making. They've already started making these doses, and so as we know, the Oxford and AstraZeneca trial has resumed, and the Serum Institute is again going back on track to continue to produce those doses. And I think India is the place we're already known as the pharmacy of the third world. And I think that the world can definitely turn to the manufacturing capacity of India to produce these billions of doses at a lower cost to supply to many, many countries on an equitable basis who need them, depending on what international arrangements are falling into place. As far as the native vaccine is concerned, the ICMR was literally given a deadline of August 15th to come out with a sort of thing, but that, as we know, hasn't happened. So we need to just keep tracking the development of that vaccine a little more. But there's nothing really to sort of to say to raise hope on any front at the moment.
Thank you very much, Dr. Jaya. And it was a pleasure having you on our Internews Flash Talks on COVID-19. Our next Flash Talk, hopefully next week, will be on vaccines and the latest development on vaccine in this COVID-19 updates by Internews. So we'll keep you posted and watch this space. Thank you very much. And thank you, Dr. Jaya. And thank you to all those following us on Zoom and also on Facebook. And hopefully see you again next week. Thank you.
Thank you, Sunny. Thank you for a good conversation.